Hello and welcome to this video on section 6.3 Truth Tables for Propositions part 3. In this video we are going to be looking at specific statements, and we're going to basically classify them as either tautologous, self-contradictory, or contingent. And this is basically a way of determining whether the truth values for a compound statement or for a complex statement depend basically just on its logical form, or whether it depends on the specific truth values for its parts or for its components. That's really what it all means. But what we really have to be concerned about here is whether we can do the truth table and whether we can determine after doing the truth table whether we can determine if it's tautologous, self-contradictory, or contingent. So the procedure here is pretty easy. If it turns out to be the case that under the main operator, so keep in mind that we're talking about the main operator here, if under the main operator the truth values are all true, then our answer is going to be tautologous. If it turns out to be the case that they are all false, then our answer is going to be self-contradictory. And then if it turns out to be the case that there is at least one true and at least one false, then the answer turns out to be contingent. So all we have to do here is build the truth table and then look at the results under the main operator, and so in this case it's going to be under the wedge because that's our main operator, and then ask ourselves what are those truth values, and then we can make that determination of whether it's tautologous, self-contradictory, or contingent. Okay, so let's quickly build the truth table for this statement here. This is B or not Q. Okay, so remember that we start here with the negation. The whole thing is a disjunction, and so there are two disjuncts, but we can't compute the disjunction here unless we know the result of that negation on the right. So we're going to do the opposite, remember, of whatever truth value we have. So that would be F in the first line. That would be F. In the second line, that would be T. In the third line, that would be F again. And then in the fourth line, that would be T, right? So notice that all I've done is I've done the opposite because that's what negation requires, right? Let's make that let's color that green just to distinguish it from what's under the main operator, which we'll do in a second. Okay, so it's the green that we're going to look at when we compute the whole disjunction, because now we have the final results under the right disjunct. We can compute everything under the wedge, right, which is the whole disjunction. Okay, so remember the rule here, that if at least one is true, the whole thing is true. If you don't remember the rule, then you have the table here. It's up here, the disjunction table, and so you could just basically compute it. Okay, true or false is true. Remember, if at least one is true, the whole thing is true. True or true is true. False or false is false, and then false or true is true, right? So that's it. That's what we have under the disjunction here, under the whole disjunction, under the wedge, and let's make those in red to indicate that that is our final answer, right? As you probably already noticed by now, all my final values are always in red, and so we have what we need here. We have the values under the wedge. Okay, notice that we have the case in which at least one is true and at least one is false, right? And so that is because we have T in the second line and we have F in the third line. So that fulfills that requirement, right? It is not the case that all of them are true, right? Because we have one false in the third line. And it is not the case that they're all false because we have three T's, right? Three lines where they're true. So this ends up being a contingency. So the whole answer here will be contingent, and that is because we have the case where there's at least one true and at least one false. Okay, so if all of them had been T's, then it would have been tautologous. If all of them had been false, then it would have been self-contradictory. So this is what you're doing in your homework. you're determining whether they are tautologous, self-contradictory, contingency. And notice that you need to know how to do the truth tables first.